So this is lesson number 39 in Algebra 2, probably the first video. I have to do two probably. Difference of two squares, parallelogram proof, and the rhombus. Alright, so to start out with the difference of two squares, one of the things that we're going to look at are called, that's an N, conjugates. Alright, so when you're doing conjugates in English, that's completely different than when we're doing conjugates in math. A conjugate in math is when you have two terms, like this, 2x plus 3y. The conjugate of that would be the exact same thing, only the sign between the two numbers is going to be the opposite. And what that means is when we multiply these two together using the FOIL method, our middle terms cancel out. So if we took and did our first, our outside, our inside, and our last, notice what we have here. This one and this one's a negative 6xy, this one's a positive. So those would cancel out and we'd be left with 4x squared and 9y squared. Okay? So, if we wanted to go backwards, and let's go ahead and write this as 4x squared minus 9y squared. This right here is our beginning point, and factoring into that is what we're looking for. So we just did the FOIL to make those two binomials into this here. Now we're going to take this and go back to that. Alright, and the key thing we have to do, and this is called the difference of two squares, and let's see if we can get rid of some stuff here. Alright, so we started with 4x squared minus 9y squared. When you're given something like that and they ask you to simplify it, there are a couple things that have to be true. Number one, there has to be a minus sign. Number two, you have to be able to take the square root of the first term, and number three, you have to be able to take the square root of the second term. If you can do that, you have what's called the difference of two squares, the difference of two squares. Alright, so what do I do with that? Make two parentheses, make one a plus, one a minus. Take the square root of the first term, put it there. Square root of the second term, put it there. And you're done. Okay? That's really all the difference of two squares is. So if I have that, because of this equal sign, that means I'm going to try to find the solution. I'm going to try to find out what x equals. Alright, difference of two squares. I have a minus sign. I can take the square root of that. I can take the square root of that. So that means it's doable. So I go ahead and make my two parentheses with a plus and a minus. Square root of the first term. Square root of the second term. Okay? And you've just factored it. Now we're still trying to figure out what x is. So either this, and again, because we have to have two numbers multiplied together equals 0, one of these parentheses has to equal 0. It doesn't matter which one, but one of them does. So we're going to set the first one equal to 0, and we're going to set the second one equal to 0. So solve for x, and we get 2x equals negative 3. Divide by 2, divide by 2, and we get x is negative 3 halves. So that would make this one 0. And let's add 3 to both sides. We get 2x equals 3. Divide by 2, cancel. And this one, to make it 0, x has to be 3 halves. So I have two answers for this, negative 3 halves and positive 3 halves. Okay, so those are my answers, and I know that because my highest exponent is a 2, so that tells me I'm going to have two answers. Alright, let's look at example 39.2. Get rid of all this. Alright, let's just go. Alright, 39.2 says we have 81 m squared minus 25 equals 0. Difference of two squares right there. Two parentheses. Don't forget my equals 0. 9m plus minus square root of 25. Okay, so we just took the difference of two squares, we factored it. Now we have to set each one equal to 0. That's always the next step. So subtract 5, 9m equals negative 5, divide by 9, divide by 9, those cancel. Add 5, 9m equals 5, divide by 9, those cancel. So the answer is negative 5/9 and positive 5/9. Those are the two options I have for m. It equals both of those numbers because it will both of those numbers will make it a true statement. Okay. So let's go ahead and start a second video for the parallelogram. No, let's not. Let's just see what we can do. Parallelogram. We've already looked at parallelograms in lesson 37, and let's just continue on with this. Okay, so dealing with parallelograms, just it's got a list of the 4 things we've already done about the sides opposite have equal lengths, and that's why they put these here. Lots of different things that are true here. Let's look at a couple of those here. Let me get a different color here. We know that this angle and this angle are the same because they're vertical, they're opposite. We also know that this angle and this angle are the same because they're opposite. We know that this angle and this angle are the same because, if you remember a long time ago when we had two parallel lines and we had a transversal cut through them, this angle and this angle were congruent because of alternate interior angles, which means then that this angle and this angle are congruent. So I mean, you just have a lot of different things that are congruent because of being a parallelogram, which means that this triangle here, the length of the sides and the angles are going to be the same, which is the same here and here as well. So the only tricky part is making sure that when you're comparing these triangles in these parallelograms that you realize that this line here is congruent to this line. And the way you can remember is if they're on the same diagonal, they're going to be the same length, because remember, diagonals cut each other exactly in half. So this one and this one are the same length too, because this diagonal cut it exactly in half. Okay, so there are some things to remember when you're solving these. In fact, they'll give you some of these and ask you to figure it out. But that brings us to what is called a rhombus. So notice this rhombus is a parallelogram, but it has 3 additional properties to it. Okay, first property is that all of the sides are the same length, whereas in a parallelogram they don't all have to be. But a rhombus is a special parallelogram. It's kind of like a squished square. Alright, the second one is the diagonals bisect the angles of the rhombus. That means that this diagonal cuts this angle exactly in half, so that 3 and 4 are the same measurement. 1 and 2 are the same measurement. In fact, if I drew a line here, this angle and this angle would be the same, and that angle would be the same. Alright, so let's see, what else do we have? We have a third point here. The diagonals of a rhombus, let's go ahead and draw that diagonal from B to D again. Diagonals of a rhombus are perpendicular bisectors to each other, so they not only cut each other in half, but in a rhombus they cut each other in half at a 90-degree angle, perpendicular to each other. Okay, so there are some things that have to do with a rhombus. So let's go ahead and look at one example here of a rhombus, 39.3, and do some solving. So this one is 39.3, so let's see what we've got here. Telling me this is 280 degrees, so that's called a reflex angle. That's 280. So that's going to tell me that these angles are going to be whatever makes up, add 280 to give me 360. So 280 plus this angle is going to be 360. Well, not even that angle because they're calling this x, so let's not even do that. Let's call this y, and we'll say that that whole angle there is y. So that means that y has to be 80 degrees, right? And what did we say? We said that each one of these angles is going to be cut exactly in half. So this one's going to be a 40, and that one's going to be a 40, right? Alright, so let's look at this angle. Well, we know that's a 90 because of theorem number 3, and it says the diagonals are perpendicular. So I know that's a 90-degree angle right there. So 90 plus 40 plus k is going to give me the angles of a triangle, which is 180. So I've got 130 plus k equals 180. So k is going to be a 50-degree angle. So let's get rid of all my stuff here, and I can put k as being a 50. We already found a is 40, found out x is 40. What else do we know? Well, if k is 50, we know b also has to be 50, right? The only other one is c, and we know that's a 90-degree angle because of theorem number 3 of a rhombus on page 178. So that's pretty much all there is to this lesson, lesson set 39. In the next video, go over some of the problems.